Good afternoon. My name is Nika Asimobi, and the problem we're going to be solving is this. My rectangular backyard needs to be fenced to stop strangers from having access to my car. To get a fence built around my backyard, it costs $5 per foot for two opposite sides and $8 per foot for the other two sides. Find the dimensions of the backyard with an area of 800 square feet that will minimize the cost. So, first thing we're going to do is sketch this model, and you can see that we know that we have a rectangle here, and that means that the opposite sides are the same length. So we're going to let these two sides equal x, and we're going to let these two sides equal y. And I went ahead and assigned $8 a foot to the smaller sides and $5 a foot to the longer sides. And now we know that the area of this backyard must equal 800 square feet. And that area is x times y. So the constraint for this equation is 800 is equal to x times y. Okay, so the next thing we're going to do is look at the cost equation. So we know that the total cost is going to equal the cost per foot times the number of feet. So that would mean cost is equal to 8x plus 8x plus 5y plus 5y. And it can be simplified down to cost is equal to 16x plus 10y. Now, this is the equation that we want to minimize. So before we do that, we're going to rewrite the equation in terms of only one variable. And to do that, we're going to go back to the restraint and solve for either x or y. So in this case, I decided to solve for y. And to do that, we just divided both sides by x, and we now have y is equal to 800 divided by x. So we're going to go back to the equation and replace y with 800 divided by x. And now we have cost is equal to 16x plus 10 times 800 divided by x. In order to minimize this, we have to find the critical numbers by finding the derivative of this function and then finding where it's equal to 0 or where it's undefined. So before we do that, we're going to rewrite this as cost is equal to 16x plus 8,000x to the negative 1, because when we move x to the numerator, it's going to change the sign of the exponent. So now let's go ahead and find the derivative of this. So see, the derivative of 16x is equal to 16, and here we'll apply the power rule. So we multiply negative 1 times 8,000, and we get 16 minus 8,000, and we get x raised to negative 1 minus 1, and that's x raised to negative 2, which we can rewrite as c prime is equal to 16 minus 8,000 divided by x squared. So next thing we want to do is, what we're going to do is we're going to equal this equation to 0. So now we have c prime is equal to 16 minus 8,000 divided by x squared is equal to 0. And when we do that, we can write 16 as 16 divided by 1 to make it easier to cross multiply. And we'll add 8,000 over x squared to the other side. So now we have 16 over 1 is equal to 8,000 over x squared. And then we end up getting 16 x squared is equal to 8,000. Then we divide 16 by both sides, and we get x squared is equal to 500. So the next thing we're going to do is we're going to square both sides. And we get x is equal to 22.4. Now, because we're trying to find a way to minimize the cost, and we only have one critical number to consider, because this is our critical number, to check to make sure that this x value, the cost will be minimized, we're going to check the sign of the second derivative at this value. So to that, here's our first derivative. We have c prime is equal to 16 minus 8,000 over x squared, which is equal to 16 minus 8,000 x to the negative 2. So at c double prime, we're going to have 16,000 x raised to negative 3. Or we can rewrite this as 16,000 divided by x raised to 3. So there we go. And now, so c double prime of 22.4 is equal to 16,000 over 22.4 cubed. And now we're just making sure that this is greater than 0. We can be sure that 22.4 is the minimum value. Because if the second derivative is positive, that means the function will be concave up. And that means that at 22.4, we have a minimum value. So that assures us that at x is equal to 22.4, we have minimized the cost. So now, going back to our equation, we now have to solve for y. And we know that y is equal to 800 divided by x. We're just going to go ahead and plug that in. So we're going to go ahead and substitute 22.4 for x. So now we have y is equal to 800 divided by 22.4. And y is equal to 35.7. So now, if we look at, so now we know that, notice that we have less feet at the cost of $8 per foot and more feet at the cost of $5 per foot. So the question asked us to find the dimensions of the backyard with an area of 800 square foot that will minimize the cost. And our dimensions are 22.4 feet by 35.7 feet. Now, if you wanted to find the total cost, it would be C cost is equal to 16x plus 10y, and that would be equal to 16 times 22.4 plus 10 times 35.7 equal to $715.40. So let's carve this out. So the dimensions of the backyard with an area of 800 square feet that will minimize the cost is 22.4 feet by 35.7 feet.